The purpose of this experiment was to determine the therapeutic potential of multisensory stimulation in Alzheimer's disease using Drosophila melanogaster as a model organism. Alzheimer's disease is a debilitating neurodegenerative disorder and the most common cause of dementia. Over 55 million people worldwide are currently suffering from this disease. The accumulation of two primary proteins, tau and amyloid beta, contribute to neuron damage, resulting in progressive neurological symptoms, including impaired memory and motor function. But there is currently no cure and limited treatment options. One promising area of research is multisensory gamma stimulation. Gamma oscillations are a type of brainwave frequency associated with complex brain functions like attention, memory, and sensory processing. Simultaneous auditory and optical stimulation in this range mimics brain waves, causes synchronized neural activity, and may stimulate mechanisms for the natural clearance of waste products and toxic proteins. The research question was, what is the effect of different frequency multisensory stimulation on locomotor activity, learning, and short-term memory in Drosophila melanogaster expressing Alzheimer's proteins tau and amyloid beta? The hypothesis was that both types of mutant flies subjected to 30 Hz of stimulation would show the most improvement because flies have shown oscillatory activity in this range associated with attention processes. In this experiment, a stimulation chamber was constructed containing speakers and mounted LED lights. A waveform generator was used to generate the desired frequencies. Groups of wild-type and transgenic flies were placed in the chamber and exposed to the multisensory stimulation at 30 Hz or 40 Hz for 1 hour for 10 days. Control groups of each fly type received no stimulation. A Drosophila activity monitoring system was used to assess locomotive activity. The monitor uses an infrared beam to automatically record activity over a 24-hour period. A negative geotaxis assay was used to measure the percentage of flies able to climb 8 centimeters within 10 seconds to assess motor function and activity. Finally, an aversive phototaxic suppression assay was used to measure the percentage of flies that learn to associate an aversive stimulus with light and suppress their natural tendency to move towards a light source. The results show that the amyloid beta group exposed to 40 Hz of stimulation had the greatest increase in activity measured over 24 hours in the activity monitor compared to the control. The amyloid beta flies receiving 30 Hz of stimulation also showed a lower but statistically significant increase in activity. Both the wild-type and the amyloid beta flies that received 40 Hz of stimulation showed slight but statistically significant increases in climbing in the negative geotaxis assay. Flies subject to 40 Hz of stimulation showed an improvement in learning compared to the control group in the APS assay, but the results were marginally above the threshold for significance. The tau flies showed no significant improvement in any of the assays. The hypothesis was partially supported because mutant amyloid beta flies in the 30 Hz group significantly increased activity measured by the DAM system, with the flies subjected to 40 Hz showing a greater increase. One limitation is that not all assays and trials can be completed on the same day due to time constraints. Completing all assays and trials on the same date would ensure that the flies are exactly the same stage of disease progression. A larger sample size would also give more precise results. Areas for future research include testing additional frequencies, durations, types of light, and tactile stimulation. Advanced imaging would also provide valuable data about the effects on protein accumulation. This research can be used to help develop non-invasive treatments for neurodegenerative diseases like Alzheimer's disease, and because the wild-type fly showed a statistically significant increase in activity, it may also support development of new methods to improve brain function in healthy individuals.